At a point 50 feet from the base of a church, the angles of elevation to the bottom of the steeple and the top of a steeple are 35 degrees and 48 degrees respectively. We need to find the height of the steeple alone. So steeple is just a tall part. So let's just say here is a church. The steeple is just a tall part on top of it. And so we're just trying to find the height of the steeple. So I'm going to draw it not on the building there, just so we can have a better picture of what we're looking at. Okay, so this blue part is the steeple. We'd have a person standing here. And we say that distance between that person and the building is 50 feet. And we're looking at angle of elevation. So from one point, it's 35 degrees to the bottom of the steeple. So 35 degrees is here. And then to the top of the steeple, it's 48 degrees. So the higher you look, the larger the angle. So that pink inside is 48 degrees. So keep in mind that's inside, that is not 35 plus 48 degrees, right? So angle of elevation, you really have two triangles overlapping. And so we have the steeple height, so I'm going to call that X, and then I'll say the building height, I'll just call that H. So we're going to write two trig ratios here. So we can start with the small triangle first, because what we do need H, and then because once we figure out H, if we find X and H, we can subtract H from the problem, from the solution, in order to find what is the height of the steeple. So let's do the small angle first. We have 35 degrees, and we have H and 50 feet. So we can use tangent of 35 degrees is the height over 50. Then now we can do the larger angle, which is tangent of 48 degrees. And again, that'll be this side right here, which is X plus H over 50. So let's go ahead and multiply each of the equations by 50. So we have 50 tangent of 35 degrees equals the height. And then on the right, we have 50 tangent of 48 degrees equals X plus H. Now our goal is to solve for X. So what I'm going to do on this right side is I'm going to go ahead and subtract H here. So then I can move it to the other side. So minus H and minus H. We therefore have 50 tangent of 48 degrees minus H equals X. And so what we can do at this point is we do know what H is. H is this 50 tangent of 35 degrees, so we can go ahead and substitute. So I'm going to rewrite it, 50 tangent of 48 degrees minus the 50 tangent of 35 degrees, and that'll give us our height in feet. So then when you plug it in a calculator, you will get the height is approximately 20.52 feet. Number 6. A passenger in an airplane at an altitude of 10 kilometers sees two towns directly east of the plane. The angles of depression to the towns are 28 degrees and 55 degrees, and we want to know how far apart are the towns. So we're looking at angle of depression, and so I'm going to draw my horizon here. I'm going to draw the airplane in here, because I want to remember that what angle I'm looking at is the angle towards that horizontal line from that passenger looking, and then they're going to look down. So one angle of depression is 28 degrees, which is right here. So that's to town 1. And then there's another town that person sees, and that entire angle is 55 degrees. Okay, so that's in total here. And so that is town 2. I do want to make them parallel on the ground. Okay, so I'm going to change that a little bit just so it looks a little clearer. Town 1, Town 2. And we do know that the height of the airplane is 10 kilometers. So we can either draw two triangles here. What I'm going to do is I'm going to flip my triangle. I want to make it so they have the same exact height of 10. So I'm going to make my 28 degrees down here. And then the 55 degrees, I'm going to change to that's up here, right in here. So I'm going to do alternate interior, so 55 degrees is in here. And then now they're sharing that same back leg, or this side of the triangle, and that we know is 10 kilometers. What we're trying to find is the distance between the two towns. So this is similar to other problems we have solved, because we actually have two different variables here. So I'm going to call the distance between the two towns, I'm going to call that x, and then I'm going to call this entire leg, maybe I'm going to call this h, and then so I really have, well, not h, let's call it y. Y plus x is the total distance here. So we're going to write two ratios. We have 28 degrees, we have 10 kilometers, and then we have this entire leg. And then we can write another trig function using the 55 degrees and 10, and then just our y. So one will be, I'm going to start with a smaller triangle. So tangent of 55 degrees equals 10 over that length here, which I gave is y. This alone is y. Then I'm going to use the smaller angle, tangent of 28 degrees. And that's still going to be 10 over, now it's over this entire leg, and so I called that two different things. That's y plus x. So what I want to do is I want to isolate my y here. So I'm going to change this. I'm going to multiply by y to both sides. So we have y tangent of 55 degrees equals 10. Then I isolate my y. So now I have y equals 10 over tangent of 55 degrees. I'm going to do the same thing here. So essentially what we did, which you could do as a shortcut, is you could just switch the spots of tangent of 55 and the y. And so I could do the same thing here, where I just change positions, because I'm going to multiply by y plus x to both sides, and then I'm going to divide by tangent of 28. So they really just change sides. So y plus x equals 10 over tangent of 28 degrees. Now we're really trying to solve for x, and then we also know what y is here. So we can actually plug that in, but what I want to do is isolate the x first. So I'm going to subtract y from both sides. So now we have x equals 10 over tangent of 28 degrees minus y, and then we do know y is that 10 tangent of 55 degrees. So we can find the distance between the towns. It's 10 over tangent of 28 degrees minus 10 over tangent of 55 degrees, and that will be in kilometers once you plug it into the calculator. There is no cotangent button, right? So you have to do 10 divided by tangent of 28, right? Make sure you have enough parentheses when you're plugging it in. When you plug it all in, the distance is 11.81 kilometers between the towns.